the reason I decided to do this talk is because, like Henry said, we've gone through this journey over the past several years with Kubernetes, and how do we deploy to Kubernetes, and how do we make things easier for ourselves and the developers to get their code up and into production, which I think is a goal of most DevOps teams. So without further ado, I'm going to go ahead and tell you who I am and why maybe you should listen to me or not listen to me. It's all up to you. So my name's Evan Haston. I'm an infrastructure architect at Clarity Software Solutions. I'm also the DevOps and infrastructure manager for Artist Republic, which is a music distribution and kind of like an artist manager on the web type company. I also own a company called Dark Matter IT and Consulting, and we help with DevOps and DevOps type of things. I'm also AWS certified. I love saying that because it took me, a little bit to learn AWS, and it's helped me learn Kubernetes over the years, or at least recently. So let's start off with what Kubernetes is. Most of you probably know what Kubernetes is, but for those of you who don't know what Kubernetes is, it's a container orchestration engine designed to schedule and maintain Docker containers. In big words, that basically means it takes your Docker containers and it does a whole bunch of stuff with them. It puts them on the worker nodes, it schedules them out, it scales them, it does all kinds of stuff. And I'll get into that later on. What is Jenkins? So Jenkins is the leading open source automation server. Jenkins provides hundreds of plugins to support building and deploying and automating projects. I literally took that off the Jenkins.io site, but realistically, Jenkins is a tool that's used in DevOps quite a bit. It's probably one of the most prominent build and deploy tools out there. And it's built with a ton of plugins because of that. So you can do anything from Gradle builds to, build your Go project, deploy out to Kubernetes, which I'll talk about here. And you can do all of that with Jenkins. There's slight variations with Jenkins. You have your Jenkins, your standard Jenkins, and Jenkins X, which is built around your the cloud integration. But today I'm going to talk about Jenkins, just your standard Jenkins. If you're going to go from your standard build process and you want to build and deploy to Kubernetes from your Jenkins box without really having to retrain your employees on how to use Jenkins X or another build and deploy tool like GitHub Actions. So why we use Kubernetes? So Kubernetes is really good at scaling applications. So if you build applications out into these smaller containers, you're able to do something called horizontal pod autoscaling. And that allows you to scale out and in as demand increases and decreases for either that specific service of the application or the application as a whole, depending on how you design your Docker containers. Most people try to design things as services. So when you, even if you're not at the point of services, you can, well, let me take a step back. You can, if you want to start with Kubernetes, you can take an application that may be fairly large, stick it in a Docker container and start out that way, and then kind of scale that out. But that becomes problematic because the Docker containers are fairly large and you don't necessarily want to scale up the whole application when only one piece of the application is being used. So most people will start to break down their services into smaller microservices and scale those independently. So you can scale up one part of your application without scaling up the other. So Kubernetes, one of the hardest parts of DevOps is rolling back if there's an issue. If you're doing it on, say, an EC2 instance or just a standard VM, you have to pull that code off. You have to redeploy the code on, depending on your setup. It becomes really time consuming, especially, if you have a server farm of, hundreds and hundreds of servers. We do have that problem where we can have an issue in production, and then we've got to roll back that code base, and it takes a little bit of time to do that, which is either downtime for your clients, downtime internally, depending on the application, and it just looks bad. So Kubernetes allows you to easily roll back, and they actually have a command for that. It's called kubectl rollback, or rollout undo, sorry, that allows you to roll out that specific deploy to the last deploy, which would reference the last Docker image. So service discovery, it's really nice and easy for services to discover each other. You can put a service out there and have it talk to another service. And it's just as easy as creating a service on the Kubernetes master or masters in this case, and allowing those to kind of talk to the service address and either talk back and forth or whatever you're going to do with those services. One of the things that we didn't do to start where I work right now is we didn't start in the cloud. And that's a real challenge when it comes to Kubernetes because you have to build out your Kubernetes setup yourself. Instead of having auto-scaling groups inside of Amazon EKS or G-Cloud's Kubernetes engine, we had to actually build out our masters by hand and then build out our workers by hand. So we used a mixture of Chef automation. For those of you who aren't aware, Chef is software designed to help you write infrastructure as code, or in this case, infrastructure as code, and then run that on the server that you want and kind of create a consistent output. So what we did is we built out our masters with Chef, and then we built out our workers. So as we scaled, we can actually build our workers fairly quickly within, I don't know, 20 to 30 minutes, probably less than that, and have them up and ready in production. The other thing about Kubernetes is the idea that you have self-healing. So one of the biggest problems with software, at least from my standpoint, especially in the Java world, is memory leaks. And what happens is that, either a memory leak happens or you didn't index something on a table, and then the application just becomes super overloaded. And it could take out the cluster if you don't have your proper parameter set. But
yeah, Ben, could you slow down a little bit, please?
Yeah, sorry. So what happens is that, say for instance, all of a sudden your memory spikes from like a gig to, 10 gigs because of an index on a table not being there. The pod will actually kill itself, and it will start back up again and start the application. So you're not stuck in that state of just demanding resources and not using them. So there's also this idea of storage orchestration. So you can define your storage programmatically and then attach them to pods. It becomes a lot easier in Kubernetes. Jenkins with Kubernetes. The reason we decided to use Jenkins over another platform is Jenkins is familiar to our organization and probably most organizations. So it was less of a learning curve. You don't have to, like I said before, hop on another platform, learn how to, define certain things on that platform, either in a YAML or in the UI. It was much easier to teach people how to run the job in Jenkins and have it create an output, right? Jenkins comes with a ton of add-ons. Because Jenkins is so popular, you have an add-on for literally anything. And there are a lot of add-ons for Kubernetes. There's a lot of add-ons for Docker, and you can mix and match as you see fit for your organization. A lot of the tools that are out there today don't actually have that ability. They don't have as many add-ons as Jenkins does, and you might be limited in your abilities because of that. Jenkins has an easy to integrate, or Jenkins is easy to integrate with Git, as probably most CI/CD tools are. So you just kind of put your Git repo in there, you match it up with the keys, and then you can pull the repo down and start the build. And then we can use Git Kubernetes API to handle deployments with Jenkins. And that is really useful when you're deploying lots and lots of Kubernetes containers a day. And the other thing that we've used it for in the past is rolling back deployments with Jenkins. So, if there's an issue with the deployment and we need to roll it back, we can actually just do that with a single Jenkins job, and it's done. It's just rolled back. So I did a diagram of the architecture, or how we would do this inside of a kind of setup that we have. I named two things test, but this is supposed to be production, so I apologize. So we do this with Jenkins and DTR, but depending on your setup, you can do it with ECR, or I think Google has a registry that you can use as well. But basically what happens is that we have a job here in Jenkins that pushes, builds your code, puts it in the Docker container, and then pushes it up to the Docker trusted registry. And then after that, we run another job that takes that same container name, and it does a kubectl set image on whatever cluster we're going to change the deployment on, and it will actually pull the latest Docker image down and start running that in production. And we do this using contexts. So on the Jenkins server, we actually just use the shell and a context. So when we create a cluster, we create the files that you need for your context. And then we create the context on the Jenkins server. And then we'll actually set the context on the Jenkins server and then hit deploy, and it will run the Kubernetes commands for whatever cluster you want to get into. And all of these, because of the way that Kubernetes works in the etcd cluster, you want to have 3 masters. etcd is what keeps track of the cluster state. So like what's where, all kinds of stuff like that. How many instances are deployed versus how many you want. any kind of thing that has to do with the cluster is set in etcd. It's basically the database for your Kubernetes. So we set up 3 Kubernetes masters and then 3 API servers. And then we use a load balancer to balance 6443, which is the Kubernetes port. And that on the back end here will go to any of these that are available. And to make sure that these Kubernetes masters are alive, there's actually a health check from the load balancer to 6443 to make sure that the master is still up. So if one goes down, it'll just load balance the other 2, and then we'll go in and we'll use Chef to bring one of these back up so that we're back at 3. And the way we do this is we have different URLs for each of the environments, and they go to the load balancer. So they're CNAMED or a record, depending on what's going on. So the Jenkins jobs to do this. So what you want to do, or what we do anyways, is to build the code into a Docker container. And then we push it to DTR or ECR. We actually do both right now. And then we deploy. So we set the Kubernetes context so that it correctly runs. And then we do this command right here. It's a pretty cool command. It's kubectl set image deploy, your deploy name, your container name, and then equals whatever your DTR is. So if your DTR is located at a specific URL, you'll set the URL and the specific path for that container. So for rollback, which is probably one of the coolest features of Kubernetes, we do kubectl rollout, undo, deploy, and then coolapp container. It would actually just be coolapp. And it would roll back that entire deployment so that you're back at the previous Docker container. And this helps if there's a service outage or if something's going on that is acting up in production that really shouldn't be acting up in production. We can just immediately pull that back. It does take some time to roll back, but it comes down to how fast Kubernetes can do a rolling push in of the old code. So the way that Kubernetes works is that you don't want to take everything out at once. You slowly start to take things out as pods come up. And that's kind of like a rolling update. And the same thing happens with the rollback. So you're going to roll in the previous container. It's going to start the application up and do a health check on that, depending on how you have your YAML configured. And then it will pull the old containers out, and the new containers will be what everything's balanced to. So one of the other things that you can do with Jenkins is you can have your workers actually run on Kubernetes. You can run it like a job, and then you kill the container post work, which is really useful because it's, if you're not using the Jenkins service or like a Jenkins pod, it's just gone and it's not utilizing resources, which is a lot different from the way that Jenkins used to be, where you'd have Jenkins workers, you'd have your Jenkins master and then your Jenkins workers, where it would schedule the jobs on the individual workers. This is just use it as you need it and then kill it when you're done. And then you can scale out Jenkins. Generally, when I do hosts, I do 2 jobs per host. Now you can kind of infinitely scale, pending you don't have really small Kubernetes instances. If you have really small instances, you can't really scale infinitely, but it's much easier to scale with Jenkins running in Kubernetes. So it's a little bit short of a presentation. If anybody has questions, you can go ahead and email me. My email's on the slideshow. And if you want to follow me on Instagram, I post cool tech pics sometimes that are somewhat fun to look at, I guess. But that's pretty much my presentation.